What do you notice about the reciprocal graph? So what we're going to do is we're going to compare what my y equals x graph looked like to my reciprocal graph, and then we're going to come up with these statements here to review. So we'll read these together in a minute, but what I want to do is just have you watch. If you turn back to the very first page of reciprocal functions, and we graphed y equals x, so just where you've got your straight line here with a slope of 1. Then we graphed the reciprocal. What happens is the shape changes completely. You've got two asymptotes, and we sometimes call this a split graph just to describe it. Okay, so a linear graph will always look like a split graph when you draw the reciprocal. So rather than doing a table of values all the time, especially when the equations get a little more complex, it gets quite time consuming and you may not know which x values to pick. So we're gonna look at another strategy. What's happened is, let's talk about, we know there's always gonna be a y equals 0 asymptote, so that's always going to be here. The other thing is that every time I have a non-permissible value, so if this is y equals 1 over x, my x-intercept becomes my non-permissible value or my asymptote. So x cannot equal, so my intercept here becomes undefined. So if I was to draw, and I'm going to end up recreating this graph over here, if I was to just draw over top of this one, that sometimes is easier. So the x-intercept becomes a vertical asymptote. So at x equals 0. I'm always going to have a horizontal asymptote in. You can put that in at the beginning or near the end. It's helpful to put it in the beginning. Okay. Then really what happened is I took the reciprocal of all the y values. So let's just do that. Reciprocal of 1 is 1. 1 over 1 is 1. Reciprocal of 2 is 1/2. Reciprocal of 3 is 1/3. 4 is 1/4, and so on. And then if I wanted to go here, I know it approaches the asymptotes, but I can look at where x is 1/2. The reciprocal of 1/2 is 2, so I can plot that up at 2. So it's sometimes easier to graph these reciprocal functions right over top of your linear function. So we're going to label this one as y equals x since I'm redrawing this. This is the reciprocal of -1 is -1. Reciprocal of -2 is -1/2. The reciprocal of -3 is -1/3. Again, I like to have something in here, so I'm going to look at, this is where x equals -1/2. So the reciprocal of -1/2 is -2. I also know that the graph approaches asymptote, so I can use that too. So again, make sure your curves don't go away. You don't want to get drawing those too quickly and make that mistake, or they can't touch or cross. So I've recreated this graph over this graph. Since I've got two graphs on there, I'm going to label this. You don't necessarily need to go back in your notes and redraw this one. We're going to do this on some other examples. Now, one of the other things I'd like to point out then, so when we read our list, is that the 2 points that stayed the same were where y equals 1 and where y equals -1. Those are called invariant points. They are going to remain the same and must always be plotted in your graph. Otherwise, we take the reciprocal of all the y values and the curves approach asymptotes, and we know where our x-intercept becomes vertical asymptotes. So that's the rules we're going to listen that are listed here, and you can take the time to write these in your notes. That the x-intercept becomes vertical asymptotes. The y coordinates are plus or minus 1 remain the same. Those are invariant points. You need to plot those. So points on the graph that remain the same after transformation has been applied. So just a reminder of what invariant points were. The curve always approaches asymptote, so that helps you guide the shape of the graph. And for any other point, and really if you just remember this rule, most of the graph just falls into place in these above rules too, is you plot the reciprocal of all y values. So if you have a y value of 2, you're plotting it now at 1/2. The x value stays the same, so you just line that up vertically. 1/2 becomes y equals 2. So we're going to use example 3 to do that. So it's often easier to graph the reciprocal function right over the top of the original function. So the next video will show us doing that.